Welcome back to Learnino. So today we will discuss about overlap save method and overlap add method.
So, overlap save and overlap add are two methods of filtering long duration sequences. So, first of all, we have to know what is the speciality of filtering long duration sequences. So, there are cases when we have to process an input sequence having long duration with a system having impulse response of finite duration by using convolution method, that is convolving two sequences. So as the length of the input sequence is large, that is we are having long duration input sequence, so it is not possible to store it all before performing the linear convolution because of the long duration of the input sequence. So in that case, the input sequence must be divided into blocks. Then the successive blocks are processed separately and the results are compiled together. So this is the process of filtering long duration, and the two methods of filtering long duration sequences are the overlap save method and overlap add method. So before explaining the methods, you have to be familiar with some of the notations. So here are they. It is X of n, it represents the input sequence. H of n, it is the impulse response of the system. Then Y of n represents the output sequence, that is a convolved result. Then Ls, it represents the length of the input sequence. Then capital M, it is the length of the impulse response. Then capital L, it is the size of new data points, that is after dividing into blocks. Then capital N, it is the size of blocks of data, and that capital N is equal to L plus M minus 1. So these are the important notations, and by using this we will move to the methods of overlap add and overlap save method. First we will discuss overlap save method. So we will be given the long duration sequence X of n and the impulse response of the system, that is H of n. So the process is given over here. First step is divide the input sequence into blocks of data. And the second step, it is perform circular convolution of each blocks with the impulse response given. And the last step is to arrange the convoluted result. So these are the three processes through which we have to perform the overlap save method. So it's better to explain the method using an example. So consider a sequence X of n of length 10 and an impulse response H of n of length 3. That is X of n is equal to 3 minus 1, 0, 1, 3, 2, 0, 1, 2 and 1, and H of n is equal to 1, 1 and 1. So here the length of the input sequence is equal to 10, length of impulse response M is equal to 3, then length of the new data points is considered as 3, then M minus 1 value is equal to 2, then the length of the block, that is capital N, which is equal to L plus M minus 1, which gives 3 plus 2 is equal to 5. Then in overlap save method we have three processes. The first one block dividing, second one convolution, and the final one arranging. So we move on to the first process, that is block dividing. So here the input sequence is divided into blocks of data of size capital N, that is 5. Now each block consists of last M minus 1 data points of previous block. M minus 1 means 2. So last M minus 1 data points of previous block followed by L new data points. So L we have 3. So 3 new data points. Okay, to form a data sequence of length, that is a total length of the block it will be capital N, that is 5. So each block consists of 5 points, in which the first 2, that is m minus 1, it will be from the previous block and followed by 3 new data points from the input sequence. And for the first block, the first m minus 1 points are set to 0. That is here the first m minus 1, that is 2. So the 2 points, it is set to 0, and then the 3, that is new data points, are taken from the input sequence as 3, minus 1 and 0. So that is the case of first block. Then in second block, the 2 points, that is a minus 1 points, it is taken from the previous block, which means this minus 1 and 0, and it is followed by 3, that is 3 new data points, it is from the input, that is 1, 3 and 2. Again in the third block, so the 2 data points, it is taken from the previous block, that is 3 and 2. Then it is followed by 3 points, that is 3 new data points from the input sequence, that is 0, 1 and 2. So here the 0, 1 and 2. Again in the fourth block, first 2 points taken from the previous block, that is 1 and 2. Then we have to take 3 points and only 1 point exists in the input sequence. So we take this one and then append zeros to complete that particular block as a 5 length sequence. So this is the procedure of block dividing. So we have 4 blocks over here with the length of the sequence 5. Okay, so that's about the block dividing. Now the second process is convolution. So we have to convolve each of these blocks with the impulse response h of n. So the size of each block is 5. So we have to consider the h of n also having a sequence of length 5. So we can append zeros with the h of n, that is impulse response. 2 zeros can be appended with this sequence, and we have to perform circular convolution with each of the blocks. So that is y1 of n will be equal to x1 of n circular convolution h of n. So the method of circular convolution that I have already explained in previous lectures, so that you have to calculate, and here I am presenting only the results. So the first convolution result y1 of n will be minus 1, 0, 3, 2 and 2. Then y2 of n, it is the result of convolution, circular convolution between x2 of n and h of n, and the result is 4, 1, 0, 4, 6. Then we have y3 of n is equal to x3 of n circular convolution h of n, which gives 6, 7, 5, 3, 3. Then y4 of n, which is equal to x4 of n circular convolution h of n, and get result 1, 3, 4, 3 and 1. So you can check it with the result. So you have to perform the circular convolution with any of the methods. And the last stage is arranging these results, these circular convoluted results. We have to arrange in a particular manner. So here it is demonstrated. What we have to do is we have to reject 2 points, that is first m minus 1 points from each of the convoluted result. So it is marked in blue color, that is from the first sequence we have to reject minus 1 and 0, and we have to take the another 3 points from the first convoluted results, that is 3, 2 and 2. Okay, and from the second convoluted result also we have to reject the first m minus 1 points, that is 4 and 1, and we have to take 0, 4 and 6. Here it is 0, 4 and 6. And from third result 6 and 7 are rejected and we have to take 5, 3 and 3. Here it is 5, 3 and 3. And from the fourth result, we have to reject first 2 points, that is 1 and 3, and we have to take the other 3 points 4, 3 and 1. So here it is 4, 3 and 1. So actually we are rejecting the 2 points, that is m minus 1 points, that here also we are taking the 2 points from previous blocks. So in similar way here also we are rejecting 2 points, that is m minus 1 points from each of the convoluted results, and we are taking the 3 data points, that is L is equal to 3. So the 3 data points from the convoluted results, and which gives the final result, that is y of n is equal to 3, 2, 2, 0, 4, 6, 5, 3, 3, 4, 3 and 1. So this is the result of filtering the long duration sequence using the overlap save method. Next we move on to overlap add method. So here also we have 3 processes. First one, divide the input sequence into blocks of data, but here the block dividing procedure is different from that of the overlap save method. And the second process is similar, that is we have to perform circular convolution if each blocks with impulse response, and finally we have to add and arrange the convoluted result. So it is also different from that of the overlap save method. So to explain the overlap add method, the same example is taken, that is x of n is equal to 3 minus 1 0 1 3 2 0 1 2 1 and h of n is equal to 1 1 1. So the length of the input sequence is 10, capital M, that is length of the impulse response is 3, then the length of new data points, it is 3, and minus 1 is equal to 2, and the length of each blocks, it is capital N is equal to 3 plus 2, that is L plus M minus 1, which gives 5. So here also we have 3 stages, that is first one block dividing, the second one convolution, and the last one arranging and adding. So here in block dividing, here we are dividing the blocks, that is a sequence is divided into blocks of data size having length L, that is 3. So 3 data points will be written and then m minus 1 zeros are appended to it, that is m minus 1 means 2. So in each block the first L data points, it will be from the input sequence, and then append zeros, that is m minus 1 zeros to that, which makes the total data size L plus m minus 1, that is 5. So it is more clear, that is x1 of n, the first is block, it is equal to the first 3 data points from the input sequence, which means first L points. So 3 minus 1 0, then 2 zeros are appended to it, that 2 means m minus 1 zeros are appended to it, then x to n, which is equal to the next 3 points from input sequence, that is 1, 3 and 2, then append 2 zeros, then x3 of n is equal to the next 3 points from the input sequence, that is 0, 1 and 2, that is 0, 1 and 2, then append 2 zeros, then x4 of n is equal to the last one, that is 1, then we have to append 2 zeros and then m minus 1 zeros, which makes 0 and 0. So that's the block dividing procedure. Then the second stage is convolution. So similar to that of the overlap save method, here also we have to perform circular convolution. For that you can refer the previous videos. Then we get 4 convoluted results, y1 of n, y2 of n, y3 of n and y4 of n. So y1 of n, it is a circular convolution of x1 of n and h of n, which gives the result 3, 2, 2 and minus 1 0. So here also we have to append 2 zeros with the impulse response to perform the convolution. Then y2 of n, which is equal to x2 of n, circular convolution h of n, and result 14652. Then y3 of n, which is the result of circular convolution of x3 of n and h of n, and the result is 0, 1, 3, 3 and 2. And y4 of n is equal to x4 of n, circular convolution h of n, and the result is 1, 1, 1 and 0, 0. So that's about the convolution. And the last stage is arranging and adding. So here, first we have to arrange the convoluted results as follows. Then we have to add these two data points, that is 2 data points from the first result and the 2 points from the second result. Again the 2 points, last 2 points from the second and the first 2 points from the third one. And we have to add the 2 data points, last 2 data points of the third result and the first 2 data points of the fourth result, and we have to continue it till it ends. Okay, so here we have 4 results. So this is the way in which we have to add and arrange the convoluted results. So the final result will be the first 3 points, that is 3, 2 and 2. Then the sum minus 1 plus 1, which gives 0, 0 plus 4, which gives 4, then 6, 5 and 6, then 5 plus 0, which gives 5, then 2 plus 1, which gives 3, then this 3, this is here, then 3 plus 1, that is 4, then 2 plus 1, which is 3, and the last 1. So this is the way of arranging and adding, and we get the final convoluted result in overlap add method. So that's it.